Hello everyone, we are going to start a new chapter, Redox chemistry. Redox chemistry involves the study about reduction and oxidation reactions together. We have the basic idea, what about oxidation reactions and what about the reduction reactions. So the terminology redox is the combination of the words reduction and oxidation. First of all, we have to understand the electron transfer process during redox reactions. Here we see that a species, preferably a cation, when combines with some electron or when receives some electron, then it is getting reduced. On the other hand, if the same reaction takes place in the backward direction, that is when the species preferably an anion, here you see this is not an anion, this is neutral, but preferably when it is an anion, then it releases some electron, then the oxidation reaction takes place. That means the species is getting oxidized. So here the illustration is with respect to some metal cation and neutral metal. Okay, here is the metal cation. When it receives some electron, then it becomes the neutral metal. So this is the reduction reaction because the cation getting reduced. And here is the backward direction reaction where the metal is immersed in its own ionic solution and there it loses some electron to become the cation. That means the metal dissolves in that solution. So that is the oxidation reaction. And altogether this forward reaction and backward reaction can be presented this way: metal cation plus electron, reversible sign, metal, neutral metal. And here is the combination of the two words reduction, oxidation equal to redox. Now, as I have mentioned that redox chemistry is the study of reduction and oxidation reactions. So here, as a part of its study, we have to take the help of some equation. The most important equation here is the Nernst equation. In the Nernst equation, we can see a lot of symbols such as E, E0, R, T, N, F, A. So some of these symbols you are familiar with them, but with some of the symbols you may not be familiar, such as R. R is the universal gas constant. T is the absolute temperature of the system or the reaction species. A is the activity. Activity means concentration. F is the Faraday. While what about the terms E and E0? Okay, so E and E0 are the redox potentials of the species which is involving in the reduction or oxidation reaction. E0 is the standard electrode potential, while E is the simply the redox potential. Now in your chemistry books you will find some contradictory things regarding the sign convention of writing redox potential. As for example, let us take E0, which is the standard electrode potential. Okay, so what about E0? Let us know about E0 first. This is the electrode potential at unit activity. Okay, and it measures the electropositive nature of the metal. That means the metal which has greater tendency to lose the electron or release the electron has a highest or has a higher value of electrode potential. And if it is taking place as at STP and at unit activity of its corresponding solution, then that redox potential becomes standard redox potential or standard electrode potential, and its absolute value cannot be measured. We have to measure the redox potential for a particular reaction or transformation with some standard value, by comparing with some standard value. That standard value is E0 value. Okay, such as suppose you have to measure the altitude of some object or of some land. So in that case, the sea level is taken as the standard. It is taken as 0 altitude. Then the mountain altitude or the altitude of any landform can be measured by taking the sea level altitude as 0. So this is that standard value in case of redox potential. This E0 value is taken to be the standard value, and then the deviation from this produces the E value. Okay, so its absolute value cannot be measured. We have to measure it by the help of some standard value, which is the E0 value. So with the help of a second electrode, the difference in potential between the two can be measured. So as I have said that there must be some difference between the standard electrode potential and the redox potential. So in order to do this, we have to take help of a second electrode. So many terminologies or so many equipments are coming out from our discussion here, such as electrode potential. So let us see what about them. First of all, the sign convention. As I was saying, that in your chemistry books you will find a lot of contradictory things regarding the sign convention of redox potential. So IUPAC, the International Union of Pure and Applied Chemistry, have approved the European convention as the standard, or the accepted. They have accepted the European convention. In the European convention, the reduction potential is written as negative. Reduction potential means the tendency to lose an electron, such as lithium metal. Lithium metal has the highest tendency to lose an electron. So that is why lithium is one of the highest, one of the metals which have highest reduction potential. Okay. In the American convention or in the US convention, this value is written in the positive sign, but IUPAC have given their recommendation towards the negative convention in writing the electrode potential of the metal for the conversion into metal cations. So this is about the convention. So you have to accept any one of them. You are advised to accept the IUPAC recommended convention, that is the European convention, not the US convention. The next terminology which we are going to discuss here is the NHE, or the normal hydrogen electrode. So normal hydrogen electrode is actually an electrode which is platinized platinum, which is made up with platinized platinum. This platinized platinum has been saturated with hydrogen. That hydrogen gas is kept at 1 atmospheric pressure, and that platinum is immersed in a solution of acid and its concentration or activity is 1. The potential this way developed is arbitrarily fixed at 0. Since this is the standard potential, so it has to be fixed at 0, but the condition is the temperature should be STP 25 degrees Celsius and the concentration or activity is 1. This way a normal hydrogen can be produced, and here is the picture of an NHE or normal hydrogen electrode, where this part, this is platinized platinum. Now one question may arise in your mind, then what about platinized platinum? What does it mean? Okay, so suppose this is the platinized platinum and hydrogen gas is supplied from this point, and the pressure of that hydrogen gas is kept at 1 atm, 1 atmospheric, and here is the solution of the acidic solution, which contains H plus ion aquated, which is maintained at 1 mole. Now question, the answer of your question, what is platinized platinum? So this is actually the electrode which is coated with finely divided platinum black. Okay, so how can we coat the platinum rod or platinum plate with finely divided platinum black? This is achieved by electrolyzing a 3% solution of chloroplatinic acid. What is the formula of chloroplatinic acid? The formula of chloroplatinic acid is H2PtCl6. It's a complex compound, acidic. So that chloroplatinic acid should contain a very little amount of lead acetate also, and its concentration is 3%, and with the help of that solution, the platinum plate or the rod can be coated with finely divided platinum, and thus we get a platinized platinum which absorbs hydrogen gas very nicely. Then that hydrogen reacts with H plus ion, and the electron transfer process produces some redox potential, and that redox potential is taken to be 0. Okay, so here, as I have said, that lithium is the species which has the highest reduction potential, that is together the redox potential, and it is negatively signed. So this is the highest value, minus 3.05. So this way the comparatively weak metal is potassium, which is placed next to lithium. So this way the electrochemical series has been made. And here for the non-metals, okay, the sign is positive. So when the sign should be negative, when the sign should be positive. When the species readily loses the electron without any effort, then this is negative sign. And when the backward reaction takes place, that means they do not want to release the electron readily. That means the species always accept the electron or try to combine with electron, then the convention is positive. Okay, so from the metal to the non-metal, this sequence, the table of sequence, is called the electrochemical series, and in that series the borderline pair is H plus H pair, which has been assigned 0 volt. For non-metals, the reaction is the non-metal plus electron equal to the metal anion. Actually this reaction takes place. They have the tendency to accept electrons, not to lose the electrons. So what are the features of this electrochemical series? The most electropositive elements are at the top, as we have seen in case of lithium, is the most electropositive element, and it has been placed at the top of the series. Okay, and what is at the bottom? That is the least electropositive or the highest electronegative combination has been placed in the bottom of this series. So that negative value of redox potential, how much it is negative, it has the greater tendency to lose the electron. So the greater the negative value of the potential, greater is the tendency for a metal to get ionized or to lose an electron. Thus a metal will displace another metal lower down the series from the solution. Let us go back to the series once again. Here, suppose you have the solution of, suppose potassium chloride. Okay, then some lithium metal has been added to it. So in that case, lithium is more active in losing its electron, so it will lose the electron and will become lithium chloride, and potassium will come out as potassium metal. Or some common thing, suppose copper. Okay, copper is placed below iron. Okay, copper is placed below iron, so iron is more electropositive than copper. So if you put some iron nail in some copper sulfate solution, then iron dissolves in it and copper comes out as precipitate, brown precipitate. So the species which are at the upper level in the electrochemical series can easily replace the cation of the species which are placed in the lower part of the series, and they become the they actually come out from the solution or precipitate it out. So here we see the example, iron nail replaces copper as copper metal, and ferrous sulfate solution is produced. Okay, so up to this we conclude our first lecture on redox chemistry. In my second lecture I'll discuss about the Daniell cell and so on. So thank you for today.